Hello everybody, this is Voron Switchwire, the latest of the do-it-yourself 3D printers from Voron Design. In this video I will present it and test the print quality and speed. If you hear for first time about Voron, go to their website at vorondesign.com. Here you can see the printers they design, support and upgrade. The Voron team is known for their excellent Core XY do-it-yourself machines that are, in my humble opinion, the best in class. Voron 0, 1 and 2 are Core XY printers, Voron 2 being the flagship. For each printer you will find CAD files, STLs, bill of materials and a manual how to build it. The newcomer Voron Switchwire was released in late August 2020 and surprised the entire community because it had a moving bed. It is not a conventional Prusa type of printer though, but a Core XZ machine. The gantry doesn't have lead screws. It uses belts in a similar arrangement like Core XY, but moving the gantry on the X and Z instead of X and Y. This allows very fast motion on X and Z and eliminates all limitations and issues you may have with lead screws. A slightly bent or desynchronized lead screw leads to nasty patterns and artifacts on your prints. No such issues here with the belt. The frame is very solid. It uses 30-60 extrusions here for the base, 30-30 extrusions here, and there are two 20-20 small extrusions for the bed and for the gantry. The gantry is quite light because you don't have any more the X motor hanging there, like in a Cartesian printer. So your X motor is here, this is the Z motor, behind is the Y motor, and you have a small motor for the extruder. So normally you have one motor less than a Cartesian printer with two lead screws. The print head is direct. This is the afterburner designed by Voron. It can use different hot ends, E3D-V6, the Dragon hot end from Trianglelab, or a Mosquito. It has an inductive probe and it has a very nice extruder using Bondtech gears, ratio 3:1. So it's a very solid print head. Normally all parts are printed from ABS. The standard color scheme for Voron is red and black. Black as a main color and red is an accent color. But okay, you can customize this. Do it red and black if you want badass. Or, okay, I wanted it fresh, so I printed green and black. It took me 5 days to print all the parts. Most of them were printed from ABS, but for some I used polycarbonate for improved mechanical and thermal strength, like the extruder, the part blower, some of the belt holders. The most important part to print from polycarbonate or another temperature-resistant material is the part blower, because it could melt from the heat of the hot end. I had this experience on my other printer using the afterburner print head. There are linear rails on all axes. If you are interested to know where I found these excellent black linear rails made by Robotdick, check the description below. Finally, something quite funny. This is the only printer that uses a retractable keychain to hold the gantry when the motors are off. My switchwire has a Minwell 3050 watts power supply at 24 volts for the printer and one power supply at 5 volts for the Raspberry Pi. The control board is SKR E3 Mini version 2 with TMC2209 drivers in UART mode. It runs on Clipper firmware from a Raspberry Pi 4. Finally, I installed a MOSFET for the hotbed. Now let's test the print quality and the speed. And because the speed means something only for PLA, I will use Filamentum PLA. My firmware configuration allows to go up to 300 mm per second speed and 2000 mm per square second acceleration. Here you see my speed and acceleration settings in Cura. I will start with maximum speed of 200 mm per second for everything except for the outer wall and the initial layer. Same for the acceleration with maximum of 2000 mm per square second. Then in the middle of the print, I will increase the speed to 150%. That gives maximum speed of 300 mm per second. And I will check how the printer will handle such speed. As a benchy, I will be printing the Voron calibration cube. Here you see the starting sequence and the automatic bed leveling. I use a bed mesh of 16 points. Here the printing speed reaches the nominal of 200 mm per second. At this stage, I will increase the speed to 150%, which should give 300 mm per second maximum speed. This is amazing speed for a direct drive, which is relatively heavy, and I didn't observe any strong vibrations going in the frame. We reached the end of the print. Total print time is 48 minutes. Let's now check the quality. It is awesome. The edges are great and I can't see any visible difference between 200 mm per second and 300 mm per second. My second test will be with a taller model, the Adelinde Dragon available from Prusa. Their print file is set at 0.2 layer height and should print for about 8 hours. I will slice the model in Cura at the same layer height and I will use a fast but more conservative speed than for the Benchy. A more close to reality max speed that doesn't stress the mechanics too much would be 150 mm per second. I will have 60 mm per second for the outer wall and the initial layer. The maximum acceleration will be 1500 mm per square second and it will drop to 1800 in most sensitive areas. Adelinde printed fine at this speed. I see two small layer shifts, but those are due to the slicer. Because it was printing overnight, I checked the print time in Octoprint. 5 hours 32 minutes. Not bad. So here are a few thoughts as conclusion. Voron Switchwire is not the cheapest machine. It costed me around $650 to build it. And for the same price you can buy 2 Ender 3 version 2 and a few spools of filament. So is it worth it? For me, absolutely. I needed a second printer, and actually back in August I bought Ender 3 version 2. I plan to make some unboxing videos, then some upgrade videos to change to linear rails, then install a decent hot end and extruder. But then I started reading between the lines, and can you imagine Creality made an in-house control board, 32-bit, with TMC 2208 stepper drivers, if I'm not wrong. So far so good. And they limited it on purpose to just standalone mode, which means there's no UART, you cannot use features like linear advance that allows you to print edges this sharp. So the printer came and I sold it unboxed, and I started sourcing the switchwire. Personally, I'm very okay with Voron Design. They don't specify the cheapest components, but they specify optimized components, which means components that are just enough to get superior performance. And I very much like that. At the end, the cost of this printer is maybe less than the one of an upgraded Ender 3. So is it easy to build? For me, yeah, it's a very simple machine, easy to build. It took me maybe 2 days to assemble it when I had everything. There is one tricky point, this one, the heated plastic inserts. This printer uses something like 40 or 50 plastic inserts. So I screwed some parts while doing this and I had to reprint. But now I'm the master of the plastic inserts, so it's something you can learn quite easily. What is also important is that this machine is supported. It is just version 1, and as for any other printer, Voron will release new versions and improvements. The Voron community is quite strong as well. You can go to Discord for having advice or technical help with the printers. And yeah, this is as much important as the performance of the machine itself. So this machine has serial number 29. Voron gives a serial number to each machine. Normally when you finish it, you present it on Reddit with a short video and they give you a serial number. So it means at the time it was built, there were only 28 other switch wires. So I hope we'll get more, and think about it. It's a great little powerful monster. So that's it from me. If I forgot to mention something in the presentation of this printer, it will be in the description. Thanks for watching and see you for my next project. Bye bye.